Right, so in this video I'm going to do some examples of questions involving indices. So in a previous video we went through the laws of indices, 9 laws of indices, and we're just going to do some basic examples of these. So for example, if you have, let's say we'll take example number 1 here, let's say we got 10 to the power of 7 times 10 to the power of 2. This is the first law of indices. You just simply add the powers. So you end up with 10 to the power of 7 plus 2, which is 9. If you have, let's say, minus 5, and we'll say that's the power of 10, and you're going to divide that by minus 5 to the power of 3. This is a division example. Again, the base is the same, so you leave the base. It's going to be minus 5 is your base. And it's going to be 10 minus 3, which is 7. So it's minus 5 here to the power of 7. Okay, now let's look at an example of a power. Let's say you've got minus 3 to the power of 3 here. Now, in this case, if you look at the sign first, you want to raise the minus to the power of 3. So minus times minus times minus will actually give you a minus, and then you end up with 3 to the power of 3 here. So if you want to write this in index form, raise the sign to the power of 3 first of all, and that will give you a minus sign, and then the 3 is just to the power of 3. So if you have, say for example, minus 3 to the power of 4, in this case a minus times a minus will give you a plus, times a minus will give you a minus, times a minus will give you a plus. So you'll actually end up with a plus. Minus to the power of 4 will give you a plus. So you'll end up here with 3 to the power of 4. So writing this in index form will give you minus 3 to the power of 3. Writing this in index form will give you plus 3 to the power of 4. And what you'll actually find is that whenever your power is odd and you're raising a minus to that power, you'll end up with a minus answer. If your power is even and you're raising a minus to that power, your answer will be plus here. It'll be plus here. So for example, if you get a question, say for example minus 3 to the power of 54, you can see that and you're asked to write this in index form, you can see that this number here is even, therefore this will become a plus. So your answer will be plus, so it'll be 3 to the power of 54. So minus 3 all to the power of 54 will be plus 3 to the power of 54. Now if it was minus 3 to the power of 67, for example, you can see that the power here is odd, so you're going to have a minus answer, and then your 3 here will be to the power of 67. Okay, so what if we had a minus in front of the bracket here? So let's have a look at that. So say for example you've got a minus, and then you've got a minus 3 to the power of 4. Well, you do this part here first. So you're going to do the power first. So again, just ignore this minus here for the moment. We'll just write it down. We won't do anything with it. I'm just going to do this bit here, and we're going to raise it to the power of 4. So as we did up here, it's to the power of 4, which is an even number. So that minus becomes plus, and then you end up with 3 to the power of 4. Now we've got a minus plus here, so our answer will just be minus. Minus plus is minus, and you've got 3 to the power of 4. So say for example we have a minus, and we have a minus 3 to the power of, let's say, 7. So in this case, again, I'm not going to do anything with this. I'm just going to write it down. So I'm just going to ignore this minus. I'm going to do this bit here. So this minus now is raised to the power of 7, which is an odd number. So my answer will be minus. And then we have the 3 to the power of 7 as well. 3 to the power of 7. So in this case, I've got a minus minus, same signs. So it's going to be plus 3 to the power of 7. Or just simply 3 to the power of 7. Okay, so let's do another example. Number 5. Okay, so we did questions like this previously. 2 to the power of minus 3, that's just going to be 1 over 2 to the power of plus 3. Or if you've got 1 over 2 to the power of 3, you work in reverse, and that's going to be 2 to the power of minus 3. Now, you can also get questions like this. So say, for example, you've got 1 over 3 to the power of minus 5. You do exactly the same thing. You work in reverse. So you take this part here and you bring it up, if you like. So you've got 3 to the power of, you change the sign here. Remember, here we had a plus 3. And when we brought it up here, it becomes a minus 3. We do exactly the same here. We've got 3 to the power of minus 5, 1 over 3 to the power of minus 5. That's 3 to the power of plus 5. You can also say, for example, 2 to the power of 7. You can also write that as 1 over 2 to the power of minus 7. Change the sign. Okay, let's move that on another bit. And this is number 6, I think, is it? Number 6, yeah. Okay, so let's look at some square roots. Square root of 49, that's just simply 7. You can also write that as 49 to the power of a half, which is also 7. It's exactly the same thing. Let's take 16, the fourth root of 16, or that's just exactly the same as 16 to the power of a quarter, whichever way you like to write it. It's exactly the same thing. And that's just simply 2. In other words, 2 times 2 times 2 times 2. 2 2s are 4, 2 4s are 8, 2 8s are 16, so that will give you 16. And so on. So they're just basic square roots. Number 7. Let's take, let's see, we'll take, let's take 100, and we'll raise that to the power of 3 over 2. Now, in this case, just write it as, you write your square root, or your root rather, not a square root. Actually, it does happen to be a square root in this particular case. You've got a 2 on the bottom, the denominator is a 2, so that 2 goes here. You've got your base here as 100, so that goes inside here. And what we're going to do is just raise the entire thing to the numerator of the fraction here, which is 3. So if you do that, do what's inside the bracket first. The square root of 100 is 10. And we want to raise that to the power of 3. So 10 cubed, or 10 to the power of 3, is 10 times 10 times 10, which is 1,000. Okay, so let's take another one. Let's take, let's say 16 to the power of 5 over 4. So again, we can draw a root bracket here. We put the 16 in here. And the 4 is on the bottom here. That's the denominator of the fraction, so that goes outside your root symbol. And we'll raise the entire thing to the power of 5. You can also, remember, put the 5 inside here, but we leave it outside here for the moment. It'll work out better. Now, the fourth root of 16, you've got to find a number that multiplies by itself 4 times to give you 16. That's actually 2. In other words, 2 times 2 times 2 times 2 will give you 16. 2 2s are 4, 4s are 8, 2 8s are 16. So the fourth root of 16 is 2. Okay, so we have 2. This is just 2 to the power of 5. So 2 to the power of 5 will give you 2 times, that's 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 2 2s are 4, 2 4s are 8, 2 8s 16s. 2 16s, 32. So 16 to the power of 5 over 4 is just simply 32. Okay, so let's move on again. And this we will try another example, number 8. Now, let's just try some division. So let's take let's take 2 to the power of 5 divided by 2 to the power of 2. That's just simply 2 to the power of 3. You can, let's take, actually we've done something like that earlier, I think, so I might just move on from that one and just do one more example. Let's take 8 over 27, and what we want to do with that is raise that to the power of 2/3. Okay, so we'll ignore this one here, that we've done that earlier. So, okay, 8 over 27, we want to raise that to the power of 2/3. So, we've got a fraction that we have to raise to this particular power. So what I'm going to do is raise 8 to the power of 2/3 divided by 27 to the power of 2/3. So remember, when you've got a fraction to the power of a fraction, all raised to a power, you just raise the numerator and the denominator to that particular power. So now we use another law of logs. So we've got 8 to the power of 2/3. So what we can do is do our root bracket, put the 8 in here. Remember, you've got a 3 on the bottom, so that goes here. We're going to put a bracket around that, and the numerator is 2, so we're going to square all of that. On the bottom, we've got 27 to the power of 2/3. So again, we'll do our root bracket, or root symbol rather. Put the 27 in here. The 3 goes here. This is what's on the bottom. Put a bracket here, and we're going to raise that to the power of 2 in this case. So we want the cube root of 8. The cube root of 8 is 2. In other words, 2 times 2 times 2. 2 2s are 4 4s, that will give us 8. So the cube root of 8 is just simply 2, and we want to raise it to the power of 2. That's this 2 here. That's all over. We want the cube root of 27. Well, the cube root of 27 is 3. 3 times 3 times 3. 3 3s are 9, 3 9s, 27. So the cube root of 27 is 3. So all of this here is just simply 3. And again, we want to square that. So our answer is just simply 2 squared, which is 2 2s are 4, 3 squared, which is 9. Our answer is 4 over 9. So there's some basic examples of using the laws of indices. We'll leave it at that for the moment.